So my name is Michelle. I am a data scientist on the research team here at CARTO. And I'm here to tell you the origin story of a tool that we've been building for integrating CARTO and Python. So who here codes in Python pretty regularly or knows somebody in their company who does? OK, good. You're at the right place. All right. We have couched this as a love story. I can't see the screens. Yeah. If we could get the title slide up. We've couched this as a love story. When data science met LI, a love story, because who doesn't love a good romance? So without further ado, like any good story, there's first a little tension. Next slide, please. Oh, do I have a clicker, actually? It's next to me, or? Thank you. Green. All right, here we go. There's first a little tension. On the research team here at CARTO, we code mostly in Python. But obviously, we use CARTO too. We need stronger Python-CARTO integrations to avoid context switching. We also found that was the same for a lot of the clients that were using CARTO. For instance, here is a typical workflow that we had before CARTOframes. First, we would perform an analysis in Python. A Python script would take some input data, do some analysis on it. In this case, it's doing a convex optimization using a separate library. And then we'd output the data to a CSV and manually upload that data to CARTO Builder. And then manually generate a map. As you can see, we had to switch contexts from our Python environment to the CARTO Builder. We asked ourselves, could we make this better? Early flirtations with what would become CARTOframes began in January 2017 at a CARTO Camp workshop. We host CARTO Camp about once a month. It's a casual meetup that happens in our Bushwick office for CARTO users and enthusiasts. And in this particular session, we wanted to show what a data science workflow might look like. We came up with a workaround solution at the time because there wasn't really a good one, a method to write data to CARTO and then also bring back a map into a Jupyter notebook, which I'll talk about more later using the Maps API. But it was complicated and it was awkward, just as flirting can sometimes be. So as you noticed from the previous two slides, we use Python a lot. Why Python? So it's the most popular language for data scientists. Now, this might be controversial depending on who you ask, but I think it's true. Python was the first programming language that I learned when I was starting out in grad school. It's a very popular language. There's a huge community behind it that is continuously writing awesome libraries and packages for data science. So we wanted to leverage that. And I also have to address what is Jupyter for those of you who don't use Python or haven't used Jupyter. It is an application that allows you to share code easily in a notebook format. The notebook style allows the code to be reproducible, allowing users to interact and run the cells as they read along with inline notes and visualizations embedded into the document. So here's an example. This is a chapter from a textbook on learning probabilistic programming and Bayesian methods. So you can see that the textbook context appears in paragraph form. You got equation embedded, and then also the graph. And so learners and users can follow along, experiment, adapt the code to their own data sets. So it's very interactive and reproducible. When I start doing a data science project, I will usually do the exploratory analysis all in a notebook so I can share it with my coworkers. And I can also build and fine-tune models in a notebook. All right, we got to talk about what we had before CARTOframes. In other words, the baggage, breaking up with the exes. So when trying to plot latitude and longitude data, trying to do it in a 2D method would probably make any good cartographer cry. So enter a suite of tools meant to help with that, and there are many choices in Python. So first, I want to talk about matplotlib, which you probably all have used. It is sort of the backbone and the first tool you use in data visualization in Python. It's widely used for all types of data viz. It's very customizable. Given enough time and code, you can probably do anything you want with it, like this. But it requires a lot of code, and it's not really easy to get a decent-looking map. Furthermore, it's not interactive. And in this day and age, we want interactive maps. So next, we have GeoPandas. GeoPandas is a geospatial extension for the Pandas data analysis package. It makes it a lot easier to go from a spatial data set, like a GeoJSON or a shapefile, to a map and do it in cartographically correct ways. But it's, again, based on matplotlib, so it still has a lot of the same drawbacks. And finally, we have Folium. So Folium is a Python package that brings together Leaflet, which is a JavaScript library, and Python. We really liked a lot of what Folium would do. It's interactivity. You can pan, zoom, scroll in the map, click. But there was still a lot more that we think we could add to it. And so we adopted a lot of the same features into our new tool. Which brings us to CARTOframes and what our tool brings to the table. CARTOframes allowed you to easily read, write, and query data from your CARTO account and create maps within the Jupyter notebook. So here's an example of an earthquake map. And here I am setting the center, latitude and longitude, setting the zoom level that I want it to load on, perhaps changing it back to a matplotlib object to create a static image. And if I want to, say, style the earthquake points, I'm changing, say, the color of the points to a certain color, or styling by a column attribute, say magnitude, something like that, and then changing the size. We can also use the CARTO torque method, which is our library for allowing you to animate by time, a time column, to animate our earthquakes. And you'll see that in a minute. And also, we have base map styling incorporated as well. So as you can see, there's an error. We have basically a builder map in here, but made by changing a few parameters in a Python function. So there's the torque animation. All right, getting serious with CARTOframes. We went really far with this title, this theme. Moving in together. So if you have a CARTO account and you have a CARTO API key and you write code in Python, you can get started with CARTOframes right away. CARTOframes has simple read-write methods that I was talking about before for interacting with your uploaded CARTO data sets. So the read method will take CARTO data set you have and deliver it back to your Jupyter notebook as a data frame. And the write method, vice versa, will take a data frame and send it as a named data set that you pass in as a parameter to CARTO. And we also have baked in some type conversions so that you don't have to worry about, maybe the timestamp isn't formatted quite right. We try to have some smart methods so that your data can play well between the different environments. We also have a query method. This is probably the one that I use the most. It's basically you can pass any SQL query that you wish you might do in CARTO Builder. You can pass that in to this method, and you would get the results back as a data frame. And so I use this most frequently, probably because you can programmatically issue a bunch of SQL queries to multiple data sets, or you can iteratively do a series of queries. And I talked before in the GIF about the map method. And so again, making mapping easier, delivering your data with a base map already, giving you those baked-in abilities to style by color, size, time. Yeah. It basically takes in a series of layer objects with style associated with that, and it builds the maps based on the layers that you've specified here. And then finally, we've started hooking up CARTOframes with some of the cool data services that we have in CARTO. So we started off with the Data Observatory, which is our repository of data. Right now, we have basically open data, so things like the US Census, Australian Census, things like that. And we've written several CARTOframes functions that help you explore, augment, and bring in data to your data frame. So with data discovery, you can explore the metadata, say, by keywords. Say you wanted to look for education variables in the US. You could do that passing a couple keyword parameters into this function. And once you have identified what you're interested in, what variable, say, like college students between the age of 20 and 24, you can use the data method to augment your data frame and have that returned as a column. And finally, we have the data boundaries, which exposes the raw administrative boundaries that we have in the DO. So we're talking things like census blocks, zip codes, EU NUTS levels, things like that. And so there you have it. CARTOframes in a nutshell. I think the most motivating factor for me in using and developing this tool is that we can't dream up everything that you guys are going to do with CARTO. So we want to bring CARTO to your analyses that you're already doing in the environment and language that you've been writing in, without context switching and thinking about APIs and data formats and things like that. We've also wanted to make it easier for mapping. So we've baked in sensible cartographic defaults. For example, we have Voyager base map as our default base map. Colors change depending on the type of your data, whether it's numerical or categorical from the get-go. Even the colors of the outlines will change depending on what base map you've chosen. And base map labels will change depending on your geometry. So if you have points, you don't want them to overwhelm the labels of where you are. And if you have polygons, you don't want them to sit on top of the label. So we've tried to adjust things like that to get you to a better looking map faster. It's the small details. And programmatic maps is really important to us. Being able to change maps just by changing a few parameters very quickly without having to point and click or redo the steps that you've taken, and be able to save that code, that's really important to us. And also because CARTOframes is, it can return a matplotlib object like I showed before. It's basically anything you can do, like subplots, adding different graphs with the data, adding titles, legends, that kind of thing. You can do that as well. So there you have it, CARTOframes features. Basically, the power of CARTO in a Jupyter notebook, leveraging data services, CARTO colors, cartographic sensibility, dynamic mapping, all within one context. Big dreams. All right, romantic getaways, the honeymoon. This is going to be a couple examples of CARTOframes in the real world so far. We started developing CARTOframes last summer, so it's fairly new, and we're really excited whenever we find that more people are using it. So this is an early adopter. This is a journalist from Massachusetts who was using CARTOframes as part of a Python script that scrapes the Massachusetts Emergency Management website for power outage data. It scrapes it every 15 minutes and then sends the data to CARTO as a data set, which then updates this map. And the script also sends the data to a Google spreadsheet for Jim to do further reporting and analysis on. So oftentimes the data that we want to work with doesn't come in the nice format that we want it to. We need to scrape it, or we need to reformat it, aggregate it in some way before we publish it. Or maybe we want different syncing intervals, very specific controllability over that. So CARTOframes lets us be very flexible with that. And so this is an example of CARTOframes being used as part of an ETL process. The next example I have is actually my own. So this animation is 100 coral reef fish being simulated, released in Hawaii. This is part of a project at the hackathon for the American Museum of Natural History for mapping plastic flow and fish in the Pacific Ocean. The package used for this animation was ocean parcels, probably a really computationally efficient Lagrangian simulator. So this is an example of being able to use CARTOframes for visualization after having done your analysis with a different package. So here's the problem. It was that in Hawaii, these scientists wanted to repopulate the coral reefs, and so they released a lot of fish at multiple sites. So in this visual, the red lines represent fish that did not settle or be recruited in marine biologists speak, in that they didn't return to the reef after being released. So for the first 45 days of a baby fish's life, they don't have the motor capacity to propel themselves against the current, so they're pretty much at the whim of the ocean. And so as you can see, a lot of the fish do not survive, sadly. But the light blue lines are the ones that did return to the coral reef. They did, after 45 days, make it back to a coral reef somewhere in Hawaii. And so therefore, the assumption is that they settled and were able to reproduce there. So in this problem, as you can see, that was just releasing one fish. If I could go back one. That's just releasing one fish at each of the release locations and simulating a trajectory over 45 days. So if you were to do this, say, every day for multiple days, perhaps over an entire season, your map would start looking like red spaghetti. You wouldn't actually have any insights out of this. So you need to do some data processing to get insights. And so enter CARTOframes. First, what the workflow would look like in Jupyter would be you'd build the simulation model using ocean parcels. You'd set your parameters for turbulence and all that. And then you'd output the trajectory data. Now, instead of mapping it right away, you can do some querying and post-gist processing on it using the query method that I talked about. So in this case, I'm looking for, I'm doing a buffer of, say, like 500 meters or 5,000 meters around all the release sites as a catchment area. And then aggregating that to an origin destination piece of data. And finally, I can send that to CARTO and map. And what we get is a connectivity map. This is showing, so in this case, it's showing that most of the baby fish remain around the big Hawaii island. And so this is just one example of how, from that first workflow that I showed, where we had to go download a data set and then upload it again, we can keep that all within a Jupyter notebook and share that document with the scientists that you're working with, say in the field or elsewhere, the American Museum of Natural History, like this. So. Finally, we hope that CARTO users who are also Python programmers like yourself will start using CARTOframes. CARTOframes is featured in a new book coming out called Mastering Geospatial Analysis with Python. It's by these guys up here. There's a full chapter dedicated to CARTOframes we're really excited about, and it also made it to the cover. So check that out, along with a bunch of other tools that are going to be available too. So cutting edge. What's next in this love story? Like I said, this is really just the beginning of CARTOframes, and it started out as kind of like an internal project for ourselves on the research team to make our lives a little bit easier in what we do. Well, we're really excited about the potential for CARTOframes for creating programmatic spatial analysis. And we were really inspired by analysis trees. So allowing data scientists to build a graph of what they'd like the workflow to be and then port that over to different data sets and adjust as needed. So this is one example of what we envision it to be. Hasn't been built yet. Stay tuned. We're working on it. We're also really excited about vector rendering. So I think Javi was talking about that before earlier in the beginning of today. So CARTOframes currently uses CARTO.js, but with the client-side rendering, CARTOframes is going to have that really smooth client interactivity right in the notebook. But there's also going to be access to other mathematical operations, ramps and binning methods that are in the vector library. And also, you can use local data with your CARTO-hosted data within the notebook in VL. CARTOVL. So we're pretty excited about incorporating that. We've written some code for that already. It's in our contrib module soon to be incorporated. So that is going to be very soon. So if you're interested in CARTOframes, take it on a date. You can go to our GitHub repo, github.com/cartodb CARTOframes, and just click Launch Builder, which is in the README. And that will spin up a Jupyter notebook environment that has preloaded examples of CARTOframes that will walk you through how to use it. And if you want to contribute, definitely we're interested. And if you have feedback, please open an issue or just come talk to any of us or me. And I'd be definitely happy to hear if you've tried it before, some new features that you're looking forward to, any questions you might have. So yeah. And lastly, documentation too. We got to point out we have a new developer center that also has the examples and more reference documentation on that, on the methods as well at the developer center. And with that, thank you for coming.